Good morning, good morning, good morning. Welcome back. It's a beautiful Monday day. This week, you guys have a 4-day week. You got today, tomorrow, Thursday, Wednesday, Thursday. Friday, you got off because of Easter weekend. Pretty good. I think you all also have Monday off because teachers have a staff development, so just be aware of that. Don't forget a couple reminders. STAR test is coming up in about a month, so make sure you know that it does count for you to graduate. You do need to pass it in order to graduate. If I were you, I'd try to pass it this year so you don't have to worry about it next year or the following year after that. You must pass it in order to graduate. All your STAR tests. I think personally this year will probably be a little bit easier because we're obviously we're in a pandemic and we're not in school as much, so we're all doing this virtually. But don't forget, it is very important. I had a question through message saying, hey sir, are we gonna have to take the STAR test online or in person? You are gonna have to come in person, so be very aware of that. Being coming in person, you need to take it here in the building. So just letting you all know you won't be able to be at home. Anyways, let's get started with today. I didn't get to do the engagement picture stuff, but you should know that we're dealing with the parabola. This parabola is the whole idea. We're using this parabola, okay? Transformations is basically we're going to be moving this parabola around. Don't worry about this today. We are using this, but don't worry about it right here. We're just concerned with the parent function, making sure that you know that we're making this guy and we're going to be moving it. This U, we're going to be going left, right, up, down, flipping it out. So just make sure we're making sure that we know we're playing with that guy. All right, there's a couple rules. Now, this is where the vertex form is a little important because we're playing with A, H, and K. Broke it up into little pieces for you. F of x plus k means we're going up. An example of that would be f of x, random number plus 9. Usually it's going to be a different, you'll see in the examples, but plus 9, okay, I know I'm going up. Next one, we're going down. F of x minus 2, something like that. That means we're going down. Be careful for these next two. Be very careful because right here it says minus and plus, but right is the positive numbers and left is the negative numbers. So just make sure you pay very close attention. Example of that would be f of x minus 3. This is telling me I'm going to the right, into the right. Then f of x plus 4. This means I'm going to the left. Negative number, so let's say this negative 2f of x, that means it's a reflection across the x. This one's very hard to see, so I'm not going to talk about it too much because it's a reflection of the inside of the parabola. That one's going to be a lot more important in the future in Algebra 2 with more functions, okay? Also, this is super intense as well. This is very hard. This is very hard because of the vocabulary. So we're going to talk about it. We're going to look at some questions so you all can know what it's basically saying, but usually we just like to use the words wider and narrower. So the functions get a little bit, you could say a little bit wider, like myself, I got a little wide over the school year, or getting narrower because I'm going to start working out and I'm going to get skinnier, okay? Hooked it up, click Desmos, click right here, boom. You got the calculator. And let's do some examples. Key things to remember, make sure you input the parent function, f of x equals x squared. So I'm gonna put that in the first line. Oh, almost forgot, don't forget you click the little tool. You just wanna put arrows. Right here, I'm gonna put x. It's not bringing up the board, no worries. X, and then right here I'm going to put 1. Other label Y, steps 1. So I have a beautiful graph coming over here. Oh, it's not going to be tight with the French toast. Oh, maybe I can use this. right there, I'm going to put the parent function just like how I put it in the notes. Sorry. Now it comes up, how ridiculous. F of x equals x squared. This is a beautiful parent function. In case we're moving this guy around, one thing I want to do is I'm going to make it dotted so I know that that's my parent function, okay? So make sure you either want it dotted or dashed. I like the dotted one, to be honest. Okay, let's change the color to black. Unless it's already done. There's black. Boom. Alright. So we got the dotted parent function right there. Let's keep going. Identify the vertex. So we should all know the vertex is right here. 0, 0. I'm going to make sure we put a nice little point. And then we input the second function, identify the vertex, and then we see what happens to the graph. So the first one's right here. You gotta put g of x equals f of x plus 6. If you're pretty good, you already saw, okay, plus 6 means something great. If you don't, that's all right, I'll help you out. So let's put the whole thing in there. What the French toast? Okay, calm down. G of x equals f of x plus 6. All right. You can't see it. It's right there. Different color. Let's talk about it. So I'm going to identify the vertex for the parent function, 0, 0, and the vertex for the next function. What happened? This is my first point, and this is my second point. As you can see, it went up. 1, 2, 3, 4, 5, 6. So we should be able to say, okay, it went 6 units up. Boom. That's all it is. We saw the function. Make sure you identify the vertex, and boom, it went up. Cool. So then right here, you have a piece of paper. You're gonna say, okay, boom, boom, boom. It went up. Next one, w of x equals f of x minus 10. Just change a couple vocabulary words. Vocabulary. Don't worry, I have trouble with this stuff too, ladies and gentlemen. Minus 10. Let's see. Oops. Okay, so I can see the blue line or purple line. I'm colorblind, so I'm not sure. Vertex, boom. There's my vertex for the first one. And here's the vertex for the second one. What happened? It went down. Let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 units down. So you can see the vertex stayed on the y-axis and it got shifted downwards 10 times. Pretty interesting, pretty interesting. So this one went up, this one went down. Let's talk about the next one. Q of x equals f of x plus 5 in the parentheses. Q f of x plus 5 in the parentheses. All right, look what happened here. Vertex is right here. That's the first point. Vertex over here. What happened? It went to the left. Went to the left, let's count. 1, 2, 3, 4, 5. So we're gonna say 5 units left. Hey, but sir, right here it says plus. Don't worry about the symbols. I mean the symbols, the signs, because in transformations it gets a little confusing just because that's the way mathematics is, okay? We're gonna use the vertex form. You're gonna see when we use it on Wednesday, how it goes opposite, it starts getting a little crazy. So just follow what the graph is telling you. It's saying, you know what, just give me a plus right here, but the new graph is going to be on the left side of the original graph. Boom. So this one was down, this one was up, down, left. Obviously, you're probably going to see the -7. -7. Boom, it went this way. Original function. I hope you all can see the original functions just staying there, because that is the origination. It's like it never moves, because that's who we're seeing and what we're changing about it. Over here, this one went to the right. How many units? 1, 2, 3, 4, 5, 6, 7. 7 units. Right. Boom. Pause it if you need to. So we went up, down, left, right. Check it out. Little star version. This is a long one. M of x -8 and -4. F of x -8 parentheses -4. Okay, so I see the transformation. Okay, something happened. Let's check it out. So it didn't just stay on the axis, now it moved into a different area. So what can we say happened? Let's count how we got there, okay? We need to use numbers on the axes, okay? So whatever you want to do. So I know it's right here. Oops, I don't want to use an arrow. I see it's right here, and I see it's right here. So you have a choice of how you want to say it. It's up to you. Me, myself, and I'm going to say, okay, I can see that it went down. 1, 2, 3, 4. This was down 4 units. And then, okay, it went this way. So we went 1, 2, 3, 4, 5, 6, 7, 8. This went 8 units to the right. Pretty interesting. So it went down and then 8 to the right. So make sure you make note of that. We're talking about the vertex. Playing with that vertex and moving it around. This is a good problem. Nice. Pause it if you need to. Catch up. I know I'm going a little fast, but it's because I need to make sure the videos are not that long. Let's keep going. All right. So right here you can see it's t of x equals 2f of x. I'm trying to go as fast as I can, guys. T of x, now the 2's in front. Oops. In front of the f of x. Let me put the 2 right there. So you can see we haven't changed anything because f of x stayed the same. But if I put a 2, boom. This function, what happened here was it went from the regular one and it went inwards. But the vertex stayed the same. So what can we say this? We can say it got thinner, but the correct word is narrower. 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 Okay? So this one went a little inward. So when you see vocabulary in your test problems, you say narrower. So make sure you make that connection. And make sure you need a pause. If you need a pause, pause. I'm going to do this really quickly. All right, 1/4. How do I put that? Put 1 divided by 4. Boom. Same type of deal. The vertexes stayed the same, but in this case, it went from my parent function went out. This one, yes, it's going to get a little chunkier, which is wider. So we had narrower and then wider, okay? So usually you'll be able to determine how it happens just from the whole number or a fraction. I'm not going to get into extreme detail because I just need we only have 1 day for this, and I just need to make sure it's as easy as possible, okay? Again, tutorials at 10 o'clock if you want a better explanation or you want to be able to see what's up, come to tutorials 10 o'clock. Right here is negative f of x. So I'm going to replace that 1/4 with a negative number or just a negative sign. Put a negative sign. Okay, okay, boom. Vertex has stayed the same, but now it's a reflection. It's like this whole thing right here is a mirror, and boom, it just went downwards. Okay, it's a negative number, right? So just make sure, okay, negative means I'm going down. All right, good stuff. Like I said, you're using Desmos for everything in this topic. Analyzing from a graph, So right here, they just gave us a graph and they want us to know what happened. Do yourself a favor. Make sure you put the parent function. Doesn't have to be beautiful, but I know we did the dotted thing. Boom, 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 boom. Something like that. What happened from my dotted to the new graph? Oh, sir, the vertex is right here. It's blue this time. Vertex was right here at 0, 0, but now it's down here. It's at -6, we know it's 6 units down. Just make sure you read the question. So it says if k of x is kx squared, which is our parent function, and p of x is k of x plus n, what is the value of n? I know we want to say 6, but right here it's a -6, so just make sure you do the little analytical part, say, okay, down means negative, so I'm going to make sure I put a -6 as my answer. Pay attention to small details. We'll make sure we go over that more later on, okay? Again, analyzing from graphs. Remember the dotted or the dashed one is my parent function. So we're going from f to h. What happened here? Oh, sir, I think it went up. Vertex is right here. Vertex is right here. This went up. Oh, right here, f to h, vertex is right there in blue. Went to the +2, this went to the right. Okay, we talked about this right now. Vertexes are in the same spot. What happened from the dashed to the solid? It went wider. Boom, same part. Going from dash to solid, this time it's going inwards. We talked about it right now. It's not wider, but it's narrower. Can't really say that word, sorry about that. Narrower. Positive, you need to catch up real quick. Alright, right here. Careful. Remember, if you need to draw the parent function, do it. Oops. Dash, 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 dash. Dash, 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 dash. Dash, 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 dash. So we're just gonna say what's happening to the graph. So one, it went negative. What's the negative aspect of it? Reflection. Make sure you know that when it flips over, that's a reflection. But, it's already there. My vertex is what happened here. My vertex went up, so it also went up. Over here too, positive parent function. Now it's facing down, so we should hopefully see that it's a reflection. And what else happened to the vertex? It went down. Again, come to tutorials, not going to be overly difficult, I hope, but of course, just come and check it out. What happened here? Vertex is right there, boom, boom, stayed the same direction, so all we did right here is we went down. Well, vertex is staying in the same spot, we went from the up portion, now we're facing the down portion, so this one should just be reflection. Boom. Transformations, ladies and gentlemen, it's fast today only because we don't have any more time and the STAR test is coming up. Literally, we are such at a big disadvantage because of time, but hey, try your best. Come to tutorials if you need to. Just use Desmos. I promise Desmos is your best friend. I don't think I have anything else, no. Desmos is your best friend. Don't forget to put in the parent function, and then everything else will give you direction on where something is happening to the new graph. Let's look at the quiz real quick. Don't forget you have extra practice if you need to look at extra practice. Okay, let's look at the quiz. Of course, I always love helping you guys with the quiz. A lot of this is word problems, but like I said, this is the parent function. This is the second equation. Tell me what happens. Is it a reflection? Is it moving right? Is it going down? You tell me what's happening, okay? It's going to be very distinctive with that -7, so just be very cautious and read carefully. Second one. Same thing, ladies and gentlemen. So right here, we're not given a graph, we're just given the parent function. Second equation. Put that in the second equation, you should be good to go. Oh, messed up right there. I'll fix it right now. I'm supposed to have F. Yeah, I'll fix it right now. I got you guys. Alright. Boom. This is actually in our examples. Parent function. Put the example. Tell me what happens. Boom. Read very carefully. I even underlined the good stuff. 9 units below, 2 units to the right. These are all parent functions. These are the transformations. So go one by one by one by one. Tell me which one went down. Tell me which one went to the right. And make sure you read the question very carefully. I made a little gesture in there, made it a little confusing. Be very careful. And the last one. Hopefully we should be able to see what that is, what transformation is happening. Just read very carefully. And go back to the notes. If you need to go back to the video, let me know. I'll be right here. I'm going to fix number 2 in a little bit. That's it for today. If you have any questions, of course, tutorials, text, message, email, whatever you can, I'll be here. Y'all have a great day.